take out your pen and paper. You can just try it out and then try to solve that. Okay. So have you everyone got the like quiz 1 marks?
Yes, sir.
No, so quiz one marks are not posted. Only qualified results are released.
Same quiz 1 or qualify. Acha, qualify marks. Quiz 1, the term students for the term student didn't came.
No, sir, the term students will be informed.
Maximum by today or tomorrow you'll get. Okay. So how was the paper? Like you would have solved that, right? How was the paper?
So the qualified paper and the quiz 1 paper was same, right?
Yeah, same.
It was like easy and easy.
It was easy and moderate.
Some 1 2 questions are a bit difficult to understand, but it's fine.
Okay, I'll just share my screen. You can see my screen, right?
So what was it? Did you ask something?
Are you able to see my screen?
Yes, sir.
Yes, sir.
Okay. So let's
Do we
start
need to
solving.
join PD, sir?
No. Solve it from here itself. Yeah. Yeah. So this is the first question. So the given problem is 2p is equals to q, where p and q are real number. Then find the value of this 4p upon 2q plus 25q upon 625q. You can solve it. It's 7:17. We'll start discussing. You can take your time. I'll discuss after 7 minutes. Okay. Have you tried? How many of you have got the answer? Are you able to hear me?
Yes, sir, I got two.
Yeah. How many of you have got the answer?
Two, sir.
Only two people. Okay. The rest of you haven't solved, or what? You didn't get, or you didn't try it?
Didn't get, sir.
Okay. Okay. See, let's solve this. I'll just solve this paper, this question. Okay. So if I want to write it, it's given, right? Something is given here. So the given thing is 2p is equals to q, right?
Right.
Correct. So what can I write about 4p? 4 to the power p. Can we write it like 2 to the power 2p?
2 square
the
whole to
same
the
as
power
4
of p, right? That would be 2 square to the power of p, right?
when what you are saying? To the power 2 p.
Whole to the power of p.
This is what is
Right.
okay.
Then that will become 2p, right?
Yeah, that also will become 2 to the power 2p, correct? Okay.
Yes.
And then you have what is there in the denominator? 2 to the power q. What about this thing? What is this? Can you write it like 25 to the power q? And then can you write it 625 as 25 plus square?
Yeah,
Then to
that
the
I
power
did.
q.
Yeah.
Okay, so you are left with what? 25q and then 25 to what is the 2p? Sorry, yeah. Now can you write it like this? 2 to the power 2p minus q plus 25 q minus 2p. This is fine, right? This step is clear.
Yes, sir.
Okay, and you already know that 2p is equals to q, so this will get cancelled and this will also get cancelled, right? So you'll be left with what? This is 0 and this is also 0. So anything with the power 0 is 1. So here
Yes.
also it will be 1 and plus 1.
1
It is
plus
2.
1.
So,
Anyone is having any issue, you can just ask me, we'll repeat it.
so can you please explain the last step?
Okay. So the last step is, if you have anything, let's for example, here it was not 2, anything, let's for example, a is a constant number to the power 0. So what do you get? Anything to the power 0 is 1, right? So here also you already know that 2p is equals to q. So this will get cancelled. Like 2p is equals to q. That means 2p minus q equals to 0. So this you'll be left with what? 2 to the power 0 plus 25 to the power 0. So this is also 1 and this is also 1. I told you anything with the any values with the power 0 will be 1. Okay, so that's why one comes from here and the other one from here. So 1 plus 1 is equals to 2. Is it clear?
Sir, I have a doubt.
Yeah.
Sir, we are using a power m by a power n formula, right? It's equal to a power m minus n. But we are not sure whether m is greater than n or m is greater than m is less than n. I mean, we are not sure whether 2p is greater than q.
Then okay, so you can take any value.
Then formula will change.
Okay, no, even the formula will change. See, even though it was 22 to the power q minus 2p, so anything, whatever it is, q is more or p is more, that doesn't matter. In the end, if it is getting cancelled, so you'll write it, right? 2p is equals to q. So if you will replace it 2p with q, you'll be left with q minus q only. Whether you write it q minus 2p or 2p minus q, that doesn't matter. Okay, because in the end it is getting cancelled. If it was not getting cancelled, then you would have thought like, if it was not equals to 0, then you would have thought like that. Is it clear?
Yes.
Yeah.
We can I did it this way, sir. 2 to the power of 2p by 2 to the power of 2. No. I did yeah, 4 to the power of 2p, right? Because it is q is equals to 2p, right? So I can change it that way. And so I got 4 to the power of p by 2 to the power of 2p plus 25 to the power of 2p by 25 to the 625 to the power of p. Then I did cross multiplication, and then I took the common terms out. Then also it would come to the same conclusion, right?
Yeah, it will come to the same value, but yeah, so this step, whatever you have followed, I guess that is a bit calculative. You are doing that cross
Right.
multiplication.
Because I was not sure if 2 to 25 to the power of 2 whole to the power of p is equals to 25 to the power of 2p. I was not sure about that.
Okay. Yeah, you can do that in that way also. Yeah. Okay, let's move to the second question. Yeah, so this is your second question. You can try it out. This will take much more time, so I'll just give you 10 minutes. You can just try to do that. And this type of problems generally comes in the exam also. Okay, big questions where you have to read it, you have to stay calm and then read it thorough and then try to solve that. Okay, so I'm just giving you 10 minutes. I'll just come at 7:40. I'll discuss that. Okay, I'll just mute myself here.
Sir, that is A naught T raised to T by gamma, no? 1 by 2 raised to the power.
T by gamma.
Okay.
Yeah. Have you tried? Have you got the answer? Or do you want more
Yes,
time?
sir.
Sir, I'm not
I
able
guess.
to solve. I've made the equation, but I'm not able to solve.
Okay, okay, no problem. Okay. So I guess 42, around 42% will be the answer.
Yes, sir.
Yeah. Okay. So let's try to solve this. So see, it's given that gamma is the half time, right? And half time is basically for any element, any radioactive element, that its constituent will get half. Okay. Okay. It will basically this is what has been written here. Half time of an element is the time required for half of the given sample of the radioactive element to change into some other element. Okay. So if it starts, let's for example, if it starts with a naught, a naught was the, you can say, the
Initial concentration.
concentration. Okay, so after gamma time it will be a naught by 2, correct? And after again gamma time, what will be the value?
A naught by 4.
Yeah, correct. So it will be a naught by 4, and again a naught by 8. So it's like a ZP, so it will reduce half every time. Okay, so this is how it is proceeding. So this radioactive element, okay, it's like basically the element is radium. Okay, radium is a radioactive element. Okay, and it's some form of isotope. Okay, it's okay. So a naught is the initial concentration. So it starts this radium element has start radioactive element has starts from a naught as a initial concentration. Okay, and it is reducing in this form. This is the equation in which it is reducing. Okay, that's the exponential reduction. Okay, and that is basically equals to the element. So after t time, it is getting reduced to a naught upon 1 by 2 t by gamma. Okay, I'm asking you at t equals to 0, what should be the concentration?
100%.
A by 2.
100%. 100%.
A by 2. A naught.
No, at when t is 0, the power becomes 0, so half becomes 1, so it is a0 entire.
Correct. A to the power 1 by 2 to the power 0. So this is basically a naught. So I'm already told you it starts with a naught, right? If it starts with a naught, that means what? In the starting point, it will be having a concentration of a naught. Okay, from there only it is starting. And then the concentration is reducing in the form of some exponential reduction. Exponential reduction with the power half to the power t upon gamma. Okay, so this is clear. So now if it reducing, so it is asking me what should be the a naught is the initial concentration, okay, of the radioactive element in the given sample. 80 is the concentration of the radioactive element after t time. So this is after t time. So this is after t time. The unit has not been given, so I guess t would be must be in the form of years. So this t is in the form of years. If radian has a half time, so half time now the, so gamma has been given to you. Gamma is equals to 1600. This is the half time. After 1600 years, a naught will become a naught by 2. Okay, and the initial concentration of radian in the sample is 100%. Then calculate the percentage of the radian in that sample after 2000 years. So there must be one idea that we'll get for sure, that if 1600 is the like the half time, that means after 2000 years that must be less than 50%, right?
Yes.
Correct. And now if you
Yeah.
have to calculate the exact value, you just put the value. So it starts with a naught and then 1 upon 2, and after 2000 years, so 2000 upon 1600. Okay, that will be the exact concentration that is left. Okay, and if you have to calculate the percentage, how do you calculate the percentage of anything? So the starting point, so the initial value, so the initial value was a naught, and what is the left? Left is a naught half to the power, I guess this must be 5 upon 4. 5
5.
upon 4.
Got it.
Yeah, and then you multiply with 100, you'll get the correct value. So this a naught will get cancelled, and then you will be left with 1 upon 2 to the power 5 by 4 into 100%. I guess that will be 42, around 42%. Is it clear? Let's for example, if this was half and the value was after 1600 years itself. After 1600 years itself, we already know that it would have changed to a naught upon 2, right? So now it will be left with what? A naught 1 by 2 to the power 1, correct? Upon a naught into 100. So this will get half into 100. So 50% is remaining, correct? Similarly, you can just calculate the value of half to the power 5 upon 4. That whatever the value you are getting, you can multiply with 100 to get the value, exact value. Is it clear to everyone?
So why did you
So
did
it didn't get
eight
42. How did you get 42? So half to the power of 5 4, right? Which is nothing but 2 to the power of 4 fifth, right? Will it be
Okay.
same?
Okay.
So 2 to the power of 4 fifth is 2 to the power of 0.8,
That will be
which is 1.74.
So here it is written half to the power of 5 by 4. So when we take a exponent, then it comes 0.4204, and
0.
a naught is 0.4204.
Then you will multiply with 100, you will get 42.04.
Yes, sir.
But I did something wrong. So will half to the power of 5 fourth not equals to 2 to the power of 4 fifth?
No, that you can't write.
We can write as 2 to the power minus 5 by 4.
Minus 5 by 4 you can write it.
Okay. That's where I went wrong.
See, 1 upon 2 to the power of 1. So you can't write it like 2 to the power 1 itself. Because here you are doing the same thing, right? You are just like making the denominator as numerator and numerator. So here it was 1 upon 1 only. So can you write it 2 to the power 1 upon 1 itself? No, right?
Yeah. Okay.
You
For
can write
minus
it what? 2 to the power minus 1 you can write.
Yeah.
This is equals to 1 upon 2.
Sure.
So here
Like
also you can write it to the power minus 5. Yeah.
so, could you highlight again that why did you write a naught half divided by a naught?
So that I was calculating at gamma is equals to 1600.
Okay.
See,
We have to use calculator
if
for
I
calculating this.
if I have to if I have to calculate at gamma equals to 1600, what will I do? At that point, the value would be a naught by 2, correct? Exactly after half time, the value will be a naught upon 2, right?
Yeah, a naught upon 2.
And if I have to calculate the percentage, I'll calculate directly, right? So 1 by 2 into 100. So it will be 50% remaining, correct?
Yeah.
Yeah, so this is what I was doing. Just to show that if you have to, because earlier we were getting a naught to the power 1 upon 2, 5 by 4 by a naught. So this will be around 42%. Is it clear?
Yes, sir.
Okay. Let's
So
move
that
to the
calculation part is something.
yeah, that calculation is difficult, yeah. But if you'll get some problem, hopefully you'll not be getting any tedious calculation.
Okay. So next question.
So,
Yeah,
but
this is
but in the given question, what we have to still use is the initial concentration, not the half concentration. But if we were required, like it would have said that
No, I didn't use I didn't use this equation is totally different.
okay,
This is
okay,
what we have calculated.
yeah, but that I got. Thanks.
Hmm. Hmm. Okay, so the third problem is this is related to the domain of the composite function f of z, and yeah, so this is your question, the third question. You can try it out. Take your time. This type of problem takes time to understand also. So take your time. 7:48. So I'll just give you 10 minutes. You can try it out. You try to solve this.
E of f of x. But f of x function is substituted in p of x.
Okay. How many of you have tried this? Here it's asking g of f, so do not get confused with f of g. Yeah. So to calculate, okay, can somebody tell me how will you proceed for this question? For g of x, if you have to calculate the domain of g of composite function of g of f, which are the two things that you can't miss it here.
So first find the domain of f, then in step 2 then find the range of f, then step 3 find the domain of g, then after that compare if range of f is a subset of domain of g, then we can say domain of f of g equals to domain of g, domain of g of f is equals to domain of g, domain of f, sir.
So yeah, so whatever he has said, I guess almost everything he has said is correct. So first of all, if you have to calculate the domain of g of f, okay, so if you have to calculate the domain of g of f, so domain means what? Can somebody explain me what is domain? What do you mean by domain?
The value of x that the function can take.
Okay, so the value of x that the function can take. Okay, so for us the function is what? For us the function is g of f, correct?
Yes,
This is our
sir.
function. Now, if I have to calculate the domain for this function, I need to check something, correct? So first of all, I have to check. I have to take care of all those values of x where fx is satisfied, correct? That means I have to calculate the domain of f, correct? I have to exclude all those values of x where fx is not satisfied. The first step. The second step is you can maybe understand with the figure itself. Maybe I'll just- So let's for example, this is fx, this is x that is going, and then we're left with fx, correct? And then again here this is the domain that you're putting in the g of x, so this is fx and this is g of fx. Okay, this is for example f function, this is g function. Okay, and then you're left with g of f. So first we have calculated what is the domain of x by values of x that will satisfy those values of x that satisfy fx. Okay, and we'll exclude all those values of x where fx is not satisfied. Then whenever, because now what I have to put, so now the function is f of gx, sorry, g of fx, sorry, g of fx. Whenever you have g of fx, that means you have to take out all those values of x where, so basically you have to calculate the range of fx. So range, you have to see that what are the range, but that range also should satisfy g of fx, correct? So whatever the values that you are getting from the fx, that should satisfy this this g function. Okay, and so basically you have to exclude all those values from the range of fx also that doesn't satisfy gx. Are you getting me? Are you able to understand?
Yes, sir.
Yes, sir.
Everyone? Everyone is able to understand this question? So basically, if you have to calculate for the domain for any of the composite function, let's for example, here it is g of fx or f of g, anything. What you have to do is, you have to take care of two things. Only two things. All those values of x that will satisfy this function, the inner function. First, you take care of the inner function, then the outer function. For the inner function, you have to take care of all those values of x that will satisfy the inner function. Okay, basically, so you have to calculate the domain of the inner function. Now, for the outer function, so the inner function you'll be having some range, because the range will only satisfy the, so whatever value, whatever, see, let's for example, if you are putting z of 1, that means here the fx is equals to 1.
And fx equals to 1 means what? This is 1 is the range of a function, fx. Okay, so basically the range of the function fx, all those values of the range of the function fx that satisfy g of x. Correct? So basically you have to calculate the range of fx. Exclude. So two step, if you are just following two step, you will be getting the answer. First, the value of x you have to exclude where fx is not satisfied, and the values of fx where gx is not satisfied. This is the two statement that you should be taking care every time. Okay, the first step is the value of x that is not satisfying fx, the inner function, and the value of gx, or basically the range of fx that doesn't satisfy g of x. Okay, that's it. Is it clear to everyone now?
Yes, sir.
Okay. If you have a doubt, you just ask me.
So in this case, f of x is square root of x plus 1, right?
Okay, let's solve this one. Yeah. So for this case, the function fx is square root of fx equals to square root of x plus 1. So what are the values? What are the domain of fx?
0 to infinity.
Minus 1 to
Or minus
infinity.
1 to infinity.
Minus 1 to infinity.
Correct. So x plus 1 basically greater than equals to 0. So you have what? You have x greater than equals to minus 1. So you are the domain of fx is equals to minus 1 to infinite. Correct? Now, for this function, what do you think? What should be the range of this function? Because this range, because now you have to take care of g of fx.
Right.
Okay. So now, whenever you are taking care of g, any function, that outer and inner function, that means you have to, because you will be putting anything as a range of I, the inner function, into the outer function, right? So you have to first take care of the range. What are the values that it can give you? What are those values that will give you? Okay, as a fx, that you will be putting in the gx. Correct? Correct or not?
Yes.
Yes, sir.
Yeah. So let's take care of fx. So what are the values that you can get it with this function?
So we can get 0, 1.
Yeah, so you can
After
get
0,
any
we get
value. Yeah,
any
so you'll
value.
be getting any values greater than 0, right?
Yes, sir.
So the range of this function will be what?
0 to infinity.
Yeah, this will be 0 to infinite. Okay, now see, if you have been given the gx function, gx has been given, what do you think should be the domain? Here, you can put any values, right?
Yes, sir.
Okay, so here the domain of this gx function is what?
Real number.
Real numbers.
Yeah, correct. You can put any values here, domain. So now that means what? So whatever you have got, the range, all the values you can put it here, right?
Yes, sir.
There is no any point where for which the g of fx is not defined, right? Because you can put whatever the values of fx you are getting, that all the values you can put inside the gx. Is not it?
Yes, sir.
Okay. Yeah. So now what do you have to? So the only condition that you have to take care is, now you have to check for x. So now the domain of this whole function would be what? Minus 1 to infinite, because whatever you have got from the domain of fx and whatever you have got from the domain of this function, you have to take the intersection, because all this should satisfy, right? Both the condition. Now you are
Yes,
left with
sir.
what? Now you are left with only domain of fx, because here you are getting all the value. Here you can put it anything, right? From the fx, because from fx you are getting 0 to infinite, all those 0 to infinite values you can put it in this outer function gx. So there is no condition on g of x. There is only condition of fx, that if you are putting anything from minus infinite to minus 1, that will not satisfy fx. Okay, and if that doesn't satisfy fx itself, how can that satisfy g of fx? Right? So that's why we have to exclude all this value from minus infinite to minus 1. Okay, so only you can take the values from -1 to infinite. So now you can see that which of the following contains this -1 to infinite. So the third statement is correct. What about the second statement? Is the second statement correct?
No, sir, because if we take -2, then the our root in negative, so we get complex number.
No, okay. See, what do you mean by this one? First of all, tell me.
So we
-3,
get -3 -1, -3 to -1, right? In that case,
-3, yeah, -3 to -1 you are subtracting from here, right?
right.
So that means what? It is again will be left with what? -1 to infinite.
No, but if -1,
Okay, let's
we are
write
subtracting,
it
right?
again. See, if I'm writing it, so let's, for example, this is a straight line, and this is excluding -3 to 5. What is that? -3 to 5. Okay, the first statement. The second statement is what? The intersection with -5. This is somewhere -5 to -1. So if both having the intersection, that means this is the case, right? That I have to subtract it from here, right? And now I have left with -3 to infinite, where I have to subtract from -5. -5 would be somewhere here. Okay, here I have written I have did some mistake here. Okay, so basically this is -3. This is 5. This is -5, right? This is -5, and then you have left with -1. Correct? So if you will take the intersection, what are you left with? So the first statement was -3.
So that will be -3.
No, -1 will not come. -1 will not come because it's not in the square brackets.
Yeah, so -3 to -3 to 5 was the first case. The second case is -5 to 1. So the common thing is here to here, right? That will get subtracted from here. So -3. Now you are left with -3 to infinite, and from there you are subtracting -3 and -1 till -3 to -1, right? -3 to -1. Correct? So now you are left with -1 to infinite. Did you get the idea, or should I explain it again?
Sir, we have to subtract -1 also, right?
Let's see that.
-1 will also cancel.
Let's see that again.
-1 will not come because -1 is not in a square bracket.
Yeah.
So -1 would be not included in the intersection. So it will not be removed from the original set.
That will not be removed from the original set. Let's see that again. -3. This is -3. This is -5. So -3. The first case is -3 to 5. This is 5. Correct? So this is the first thing. Now you have what? This is the intersection, and then -5 to -1. This is -1. Okay, this is the second case. And all these cases, you can see that -5 is not excluded. -3, if you see that in the second case also -3 was not included, 5 was not included, -5 was not included, -1 was also not included. Okay. Now you will see that now if you are doing the intersection of both these cases, you are left with what? -3 to -1. See, are you able to understand this?
Yes, sir.
Okay. So you are subtracting something from here. -3 to -1. Okay. And here, if you will see that -3 will be taken, but -1 is not taken.
The intersection is the -3, -1, and it is from the first bracket under.
Okay, see, the first case is -3 to 5. -3 to 5 means -3 to 5, and both are not included. So I'm writing it as not included, not included. Correct? Then again -5 to -1. This is also not included and not included. Correct? If I'm taking the intersection, now we are left with -3 to -5. This is the common area, right? This is a common area.
Yes, sir.
But in both the cases, you can see that -3 is not included also, -1 is not included here. Correct? Is it correct?
Yeah,
Yes,
sir.
sir.
Okay.
Where's the -3 and -1 not included?
So then -3 will be square bracket.
One sec. Why -3 is in square bracket? -3 is also
After
not included, right?
intersection,
Sir,
It's not.
-3,
after
-1 not
intersection we'll
included.
get
I did not
-3.
understand in that part.
See, you just take care of this thing, right? I'm just discussing this area. Not
Yes.
I haven't entered into. Yeah. Okay.
The intersection is the -3, -1.
Huh. Yeah. Correct. Okay. So this is the
But
intersection
sir,
that you're getting from here.
-3 is included, right? In the intersection.
How -3 is included? Tell me. -3
Intersection it
is
Because we take the common part between -3, 5 and -5, -1. And if we take between these two coordinates common part, then it will become the -3, -1.
see if I'm representing here in the straight line. Just focus here. Okay. -3. The first case is -3 to 5. -3 is not included. Wherever it is not included, I'm just circling it. -3 and then 5. 5 is also not included. Correct? Now let's example -5. -5 is also not included. And then -1. -1. If I have to take the intersection between both the cases, the first case was here to here. The second case is from -5 to -1. Correct? If I have to take the intersection, both the cases, you can see that -3 is not available in the first case itself. Correct? If -3 is not available, if I'm taking the intersection, how can -3 come? It can't come,
Yeah.
right? So that's why -3 to -1. And -3 to -1, where -3 and -1 is not included. So both, it's the open bracket. Did you understand this?
Yes, sir.
Okay. Now I have to subtract it from -3 to infinite. Okay. And here also -3 was not included here. Okay. But here we don't care about that. We just have to care about that -1 to infinite should be. If -1 to infinite if you are getting, that means that should be the answer. So -3 to -1. Okay. Then again -3 to infinite from here to here -1. I have to reduce it. Because as you already know, the sets where I have to the function that I have to remove is from -3 to -1, and here also -1 is not included. That means that will be included here. Okay, so that's why our answer would be -1 to infinite, and that should be close. Are you able to understand this? Did you get the idea?
Yeah, it's clear.
It's clear, right? Anyone is having any issue in this? If you have anything, you can just ask me. There's no problem in that.
Will the questions for calculating the range could get very complicated, right? So will we get some complicated questions
No,
about
no, there won't be anything. Yeah, that will be simple. Yeah, you'll not be getting any complicated thing where you are not able to calculate the range of the inner function. Okay.
Yeah, one question. So
Yeah.
here the range of f of x we are sorry, the domain of f of x you are telling us -1 to infinity. So that is clear. So coming to the range of f of x, I saw that it is 0 to infinity. So that portion I'm not clear.
Okay. So this is x plus 1. This is fx. Okay. So the domain you are clear, right? -1 to infinite.
Domain is clear.
So what do you think for this for any root function, any of the fx, any function? What can you get it here? Maximum you can get, because you can't get negative value, so you can get 0 here. Maximum you can get 0, like minimum you can get 0, and 0 to infinite you should be getting. Okay. Now let's see for this function, because you already know that in your domain -1 to 0 is available, so you can put it here -1, right? Whenever you'll put it -1, so the minimum value that you can get is 0, right?
Yes.
And as you know that in the domain itself you can put any value. So if you are putting any values here, like for example some infinite, So here also you'll get infinite, right? So from 0 to infinite you can get it. So that's why 0 to infinite should be the range.
Okay, my understanding is that we will be substituting the value of x. So if -1 is coming there, the f of x will come as 0.
Correct.
So I was considering that it should be -1 to infinity, even the range.
No, range won't be, because -1 you can't get in any of the square function, root function. You can't get -1, right? Because
Yeah,
this
because it is a
value will
complex
always be
number.
positive.
But if you substitute f of x as -1 in this value, so -1 plus 1 becomes 0.
No, no. Okay, let me. So this function x plus 1. So to get -1, what are the values that we'll be putting here for x?
-2.
So you can't put the -2, right? Because minus your domain is what? -1 to infinite, correct?
Yeah.
So you can put the minimum value as -1 and maximum as infinite, right? You can't go to -2 itself. So your domain itself is -1 to infinite. They're the values that you can put it in this function. You can't put -2 here. Even though if you'll put -2 also, you'll not get -1 for sure. Because there you'll get a complex number.
Complex number. Yeah, agree. That portion agree.
Yeah. Yeah. Then you can't get -1, right? In any case, you can't get. Even you can't get any minor negative value from this function, from root of x plus 1.
Okay. Yeah. Thank you.
Yeah. Okay. Anyone is having any issue in this?
Sir, the range of f of x becomes input for g of x, right?
Correct. Correct. Yeah.
So then what we will do? We know that range is 0 to infinity of f
0
of
to
x.
infinite. Okay. So now you are already knowing that the range of the function is something 0 to infinite. Now you will see that what is the domain. So because in the end, what you have to care? G of fx. Okay. This you have to calculate the domain, right? Domain of this function, the whole function. Okay. So first you calculated the x values where fx is satisfied, and then from there you calculate the range value. You took out the range such that to just take care what are the values. So because this gx function will always be taking all the values of fx means the range, correct? Now you see that which are the values that where the gx is not satisfied. Okay, but for this function gx is satisfied all the places, right? You can put any values inside this x square minus 1. You can put any values, that means any values of fx, that means the range of fx can put inside this, put into this gx, correct?
Yes,
so
sir.
that's why, yeah, so there is no obstruction from gx.
Yes.
You can put anything because whatever the values are there in the range, so there is no obstruction from this function, from the range of fx, correct? See, if there was some condition, let's for example gx was not satisfied, if it was written something like gx is not satisfied at x, so that in the domain you don't have x equals to let's for example 1, you can't put x equals to 1, right? So then what you have to do is then you have to exclude those all values of x, okay, where fx was equals to 1, correct? Because g is not satisfied at 1, so that's why you have to exclude the values of those x where fx is equals to 1, correct? Did you get the idea? I'll explain it again. See, what I said is, so you were having some function fx, okay, and you have now gx. Now it's given is you have calculated. So two step you have to follow. The first step is you have to exclude the values of x where fx is not satisfied. The second case is you have to exclude the values of x where g of fx is not satisfied. Okay, now consider second state. First is clear to everyone that fx you have to just calculate the domain of fx. The second case is, let's for example, g of 1 is not satisfied, not possible. That means in this function gx, 1 is not in the domain. That means 1 you can't put. 1, if you want, you can't put. That means what? G of f of x. See, this fx can't be equals to 1. So you have to exclude all those values of x where fx was equals to 1. Right? So you have to exclude the values of x where this fx is not equals to whatever the possible value was there for the domain of gx. Is this clear or is this confusing?
Confusing, sir.
It's clear, sir.
Okay, so what I was saying is, see, for
Actually,
this
sir,
problem, see, for this problem it was pretty simple, because for this problem you didn't basically whatever the, because for this problem gx, for gx there was no condition where gx was not defined. For all
Sir,
those values,
in second
yeah,
case, you were discussing about, sir, excluding. So we are excluding from the range of fx, right?
from the real number itself you can see that. See, okay, okay, that is also again confusing for you. Okay, let's for example, okay, one second, I'll just give you one question, maybe that will clarify. I'll have to search that. One second, I'll just give you.
So here range of fx becomes the domain of G, right?
Just give me 1 second. Okay, I have one problem. You can just
Sir,
try to solve. Yeah.
before we go there, if we go back to the previous question, over there we determined that the range of f of x was 0 to infinity, right?
And
So
all those values were satisfied for gx. You can't find any values where gx was not possible.
right. So
Yeah.
then why did we go for -1 to infinity rather than 0 to infinity? Because the range of f of x is 0 to infinity, not -1 to infinity.
That's correct. That's correct. But the one problem again is, you have to take, if see, you are writing what g of fx,
Right.
correct?
Mhm.
If let's for example, so, and fx is satisfied from -1 to infinite.
Right.
If you are taking, let's for example, if you are taking 0 to infinite, that means you are taking 0 to 1, correct?
Right.
0 to 1 also you are taking. If you are taking, if you are just considering that, I just according to you, you just take care of g fx. If fx, because fx has a range of 2 to infinite, that means all the values from 2 to infinite I will put it here, and then gx is satisfied, right? This is what you are saying. But there is one catch. So for those from 0 to infinite, the fx should also satisfy, like there should be some values, right, for fx, because fx is not possible itself from 0 to -1. From 0 to -1, fx itself is not possible. And if fx is not possible, how can you get g of fx?
No. 0 to -1, f of x is possible.
0 to
Here
minus.
in our previous question, -1 to 0.
Oh, sorry.
Right?
Yeah. You, okay.
Right. So my question is, since the range of f of x is 0 to infinity, while domain of f of x is -1 to infinity.
See,
So
0 fx is there, right? The domain
right.
is what? It's -1 to infinite,
-1.
correct?
Yes.
Yeah. Okay. So now the
But
range
its
of this
range,
function is what?
but its range is 0 to infinity, right? So that's the
0 to
input
infinite.
for G. Yeah. If we say -1 to infinity, that means range is becoming -1 to infinity, which is not possible.
No, what you're saying, I'm not able to get it. See, -1 to infinite, you can put inside the fx, right? All those values fx, correct? It's correct.
Those are
or
not values of f of x, right? Those are values of x for f of x. Those are values of x for which f of x is defined, minus 1
Yeah,
to infinity.
those are, yeah, correct. These are the values of x where fx is satisfied. Okay, and
Right.
okay, possible. Okay, and now 0 to
Now
infinite
we
are
are
the
saying
values.
whatever is the output of f of x is what we
Hmm.
will give as input to g of x.
Correct, correct, correct.
And the output is not minus 1 to infinity, the output is 0 to infinity.
Yeah, that is 0 to infinite, correct.
Then the domain of g of x becomes 0 to infinity.
No, no. But 0 to
Yeah,
infinite, if
but we
you are
have to
taking,
take intersection.
what?
We have to take intersection. Intersection of domain of G and range of F.
Domain of,
So we have to take the intersection, right? Intersection of domain of G and range of F. So we take minus 1 to infinity.
see,
How can intersection bring minus 1 when we are one value is starting from 0? That does
no,
not make
that
sense.
can't be intersection. Yeah. See, what I am saying is, see, fx, this values was possible, and for gx, you can put anything, right? So this
That's
is
right.
not the, so gx is like, see, if you will calculate the domain of this function, domain of just the gx, so domain of gx is what you can put anything, right?
That will
Right.
be R. Yeah.
Yeah, that will be r, correct.
Okay.
Correct. But there is a
Right.
condition, right, that we can put x as minus 1 to infinite only.
X value we
You're
can
not
put,
getting
yes. X value is
x.
minus 1 to infinity, but f of x is not minus 1 to infinity is what I'm saying.
F of x is not minus 1 to infinite, that is fine, but f of x, you can, whatever the values you are putting, that will be available, that you can put it inside gx, right? Okay, let's solve another example that will clarify your doubt. Okay, because you got stuck with only one example, that can be a possibility. Let's solve one more question and that will clarify your doubt. Fx equals to, where is this question? Okay, so you have fx equals to 2 upon x minus 1, and now gx is what? Gx is 3 upon x, and now you have to calculate the domain of f of g. So the first step is you just find the values where, so basically the domain of gx. Okay, so you calculate the values of x where gx is not defined, that will exclude the first case. The second case is you'll find the values of all those values where gx is not defined in the domain of fx. Okay, so this is the question. Now try to solve this. I'll just give you 1 minute, you just think of that, how will you go? Have you solved this? Have you tried this?
Yes, sir.
So the first step is what? The first step is what?
First step is to find the domain of g of x.
Okay. What is the domain of gx? You can put it. You can put
Minus,
anything.
yeah, except 0.
R minus 0. R minus 0, correct?
Right.
Right. Now the second step is, so your function fx is not defined at x equals to 1, correct? Your function fx is not defined at x equals to 1, right?
Right.
Yes, sir.
So you have to exclude all those values where gx is equals to 1. So basically exclude the values of x where gx is equals to 1, because gx is equals to 1, it can't take, right? F of a1 is not possible. F of 1 is f of 1 possible? No, right? F of 1 is possible or not?
Not
possible.
No,
F
sir.
of 1 is not possible means what? We are putting what? G of x, right? That means g of x equals to 1 is not possible. So
Right.
we have to exclude all those values of x where fx is equals to, gx is equals to 1. Correct?
Right.
Right? So I have to exclude which value? 3 upon x equals to 1. I have to exclude x equals to 3 also, right? If I'm excluding 3 also, so the answer should be 0 minus 3. This should be the answer, correct? Is it clear to everyone or not?
It is clear, sir.
It is clear. Now come to the previous example. What was the previous example? See what? I guess the doubt here was, if the range is 0 to infinite, how can I put minus 1 to infinite? See, the range, whatever you have said is totally, till now it's correct that the range is 0 to infinite. But the issue is you can put any value, right? G of f. So the range of fx is fine, 0 to infinite. But the if let's for example, you are taking, so you are saying that minus 1 to 0 I can't take. Let's for example, I took minus 0.5. At 0 minus 0.5, see, at minus 0.5, the fx is possible, right? If fx is possible, then why can't I put inside gx itself? Because if fx is possible, I will be getting some values, right? Some values as a range, because minus 0.5 is possible, so I can put it here, so I can get the value. So that means I can get some values here, right? So that is possible. Are you getting me or not?
But minus,
So means
at
because
minus 1, what happens, sir? At minus 1, what happens to
At
f of
minus 1, see, at minus 1, the function value will be 0, right? Correct? Fx value will be 0. Fx, f as minus 1 is 0, correct?
Right.
Huh.
Okay.
Can you, so is g of 0 possible? Because z can take anything, right? If g can take anything, so there is no issue in z. So g of
does
0
not
is
have an
possible.
issue.
What?
G does not have an issue, but what I
Huh.
was thinking.
See, you told me f of minus 1. F of minus 1 is 0. So that means f of minus 1. Is this possible? Is this possible or not?
F of minus 1 is possible.
Correct. So g of 0 is possible. Well, there is no condition in g. So you don't have to worry about g itself. You don't have to take care of range, what is the range and all. If the range is if range is subset of gx, you don't have to worry about anything about the gx. You just take care of the x that is outside. Okay. So in that case
please
also,
move to
if you are
second
getting
question.
confused, you just think of g has a what? The domain as r, and the outer domain is what? X. So you take the intersection of r and whatever you have got outside, minus 1 to infinite. That will be your answer. Okay.
Okay.
Is it clear?
Yeah, but second one itself, I flunked in the second one also.
The second question.
Because yeah, I was thinking like x cannot be 0.
X can't be 0. See, here it is f of g. So earlier it was g of x. Here it is f of g. So now come step by step. The first step should be, I have to not include all those values of x where x is not possible for gx. Okay. So you have to exclude all those values. So I can see that for this g function, all the values are possible except 0. So I have to exclude 0, right? So I have excluded. So first step was to exclude all those values of x where gx is not possible. Now the second step is, because you already know that this is a function of f of g, that means I have to take care of all those gx, so that as a range where where fx is possible. So now you come here for this equation, you can see that f of 1 is not possible.
Right.
This is the only condition that I can think of where f of 1 is not possible. If f of 1 is not possible, that means I have to exclude all those values where g of x is 1. Because here, if you just want to write it like this is basically f of 1 is what? Where the function value where gx is equals to 1, right?
Okay.
Correct? So that means I have to exclude all those values of x where gx is equals to 1. So if I have to exclude those values, then I have to exclude what? 3 upon x equals to 1. So I have to exclude x equals to 3. X equals to 3 can't be possible.
Okay. Yeah.
Is it clear?
Got it.
Or should I explain it again?
So this one is clear.
Okay. The above
Yes,
one,
sir.
that also. Okay, it's clear, right? Okay, so let's. Okay, what happened? Set. Okay. Okay. Let's move here. Now the next question is this one, the fourth one. Take 5 minute time, try to solve this. If that the domain question is clear, right, to everyone, and that's important also, that we will be getting most probably in the exam also. Yeah.
So please show sub questions.
Sir, what's the question here?
Hello, sir. Are you there? Hello.
Yeah.
Actually, my net was stuck, I think.
Okay.
So it is freeze sometime.
Okay. Now you can see the screen, right?
Yes.
Okay. Try to solve this. Yeah. So it's pretty simple. You have been given the equation at which the population is growing, I guess. In a survey, the population growth. This equation has been given. You have been given the growth percentage also, and then you have been given the time also. You just have to put it with the answer, I guess.
Sir, are you there?
Yeah, I'm here. I'm here.
So, we can assess this instructor slides that I use in the tutorials.
It's there on the portal. I guess that's there in the supplementary content.
Okay, let me check it. No, sir, it's that slides are not available there.
Which slides?
That are using the tutorials, weekly tutorials.
Tutorial. Okay.
Yeah,
Yeah,
could you
that I
please?
guess is. I have to check it. Where is that? I have to check it. Yeah.
Okay, because I was thinking of printing and doing these exercises because one of the previous weeks I skipped a few, so it will be better that if students can access that PDF.
Okay. I'll check, and then if it's there, I'll try to upload those. Okay, I'll get back on that. Yeah. Maybe in
Okay,
the
thanks.
next session, I'll update you on this.
Okay, thanks.
Okay. So have you tried this? Have everyone tried this? So this is a simple question where your equation has been given. So you can see that the equation is what? Alpha naught 1 plus d by 100 to the power t, right? T is the time has been given, d is the growth, and alpha naught is the starting population. Okay, so you have to calculate it, and basically have been given that 30,000 was the starting population. So basically this is 30,000, 30k, and then your 1 plus the growth is 4%. So basically that is 0.04, or basically you have to write it as 4 here. 4 upon 100 will be 0.04. So 4 upon 100, and the time is you have to calculate in 2020. The starting population is from t 2015. That means 2050 will be t equals to 5, right? So this is what you have to calculate. What is the value you are getting? So this is basically 30k into 1.04 to the power 5. This is your answer. This is the
36,500.
population.
Yeah.
36,500.
500.
Yeah, this is your answer. Clear to everyone? This is simple, right? This was pretty simple. Now come to the last question. So this is your last question now. You have to calculate this. So you have been given the function fx. It's a restrict domain is also fixed 0 to infinite. Then choose the points, because if fx was there in for all the cases, inverse was not possible, right? Because that was not 1 1. So if I'm just fixing the domain from 0 to infinite, now it becomes 1 1. Then choose the points where the graph of the function fx and f inverse x is intersecting. This is pretty simple. You don't have to. It's not that difficult also.
Can you show the fourth question? My
Okay. Okay. Yeah.
Sir, can you please explain it again to
Okay.
understand it properly?
So what I was saying is, so the function. So here it has been given that how is the population is growing with some equation. So the growth of the population is with time t. After time t years, the population that was alpha naught in the starting has grown to 1 plus d upon 100 to the power of t. T is the time or the year that it took. Okay, d is the population growth, that the ratio at which the population is growing is the d, the per year growth of the population, and alpha naught is the starting population. So you have to calculate that. There is a place called ADR. Earlier the population was 30k in the starting. So at 2015 it was 30k, so 30,000. And now the population growth here is 4% per year. So this is basically 1 plus 4 upon 100. And then you have to calculate in 2020. So you started with 2015 as a t equals to 0. So 2020 will be what? T equals to 5. So after 5 years, it's asking your population. So basically this is 5. So whatever the answer that you are getting, I guess 30,000, 36,500. That's the population after 5 years of this place ADR. Is it clear now?
Oh, yes, sir. Understand.
Okay.
Yes, sir.
Let's solve this one. You have been given a function fx, I guess, and then you have been given the domain is also fixed here.
Can you explain what is the inverse function, sir, so that we can work on this?
Okay, I'll explain it. Okay, let's wait. If somebody solves it.
Restricted domain means?
Restricted domain means I have just fixed the domain. So if you'll see that fx, if you'll draw the fx will go something like this. Now I'm fixing because it was from minus infinite to infinite. Now I have fixed the domain from 0 to infinite. That means the other part will not be there. So the only one part will be there. Correct? So I fixed the domain. So now the function's value should only, I can take the value from 0 to infinite, not the minus infinite to infinite. Okay?
Okay.
Yeah.
So I have one question related to this. When we are calculating this inverse function, that is initially a function is given in terms of x, y equals to some x. Yeah. Now to find the inverse, what we do is we find this same equation x in terms of y.
Correct.
So after doing this, that it will know that we have done this transformation and evaluate the equations in correct manner. Do we still require to check that f of g equals x and g of x equals x?
I don't think so. Because that's the condition that you should be checking for any function whether it's a inverse or not.
Okay.
Okay, if you have a doubt, you can just check with that. If of like gf, if you are putting, you'll be getting g of fx as same as f inverse.
Okay, so that can be only employed if for rechecking.
Yeah, just for recheck. If you have a confusion in that, you can just recheck.
Okay,
And
thanks.
that's possible only for the one function. So that's why the restriction is there for the domain.
Okay, yeah, got it. Thanks.
Hello, sir. Hello.
Yeah.
Please explain one.
I'll explain this. Try to solve this one, then we'll explain it. Maybe after 2 minutes, I'll explain this.
So it is option 1, 2, and 4, I think the correct answer.
Okay.
Because if I took the 0 in case of x, if I take the value of x is 0, then y becomes 0. And if I take 1, then y become 1. If I take 2, then y become 2.
Okay.
So I think option 1, 2, and 4 is the correct answer.
Okay. So for this function, what should be the value? If you have a fx equals to x square, what should be the f inverse x?
The
You
root
already know
of
the
x.
domain is fixed. Root of x. Okay. Basically, this can be calculated like x equals to root y, and then you can replace it with x, so it is root x. Okay. One more thing. So the inverse of any difficult questions won't be asked. It's like you can be asked pretty simple. I just give you some example. You can just try to calculate the inverse of those functions. Let's, for example, you have a function fx equals to x minus 5, 2x plus 3. That should be f inverse x. So this is pretty simple. I'll just solve directly. I will not. So basically, you'll be see. First of all, you'll not be asked for this type of questions. Also, you'll be asked, okay, you have been given fx and then you have been given gx, and whether tell me whether the fx gx is the inverse of fx or not. Okay. See, for this function, are you able to hear me or not? I'm audible,
Yes,
right?
sir.
Okay.
Sir, here fx and append
What
inverse
fx
of
is?
fx is intersection, so both are equal. No? That means it is the x square only, not like that.
I didn't get you. So what did you say? See, fx. So till now it is clear. Fx is x square. F inverse x is root of x, right?
No,
Is this
sir.
clear?
No, I didn't understand that part itself. I'm trying to get that.
Okay. So what I was saying
Fx,
is, see, if we have a fx equals to root x square, what was the function? The function fx is equals to x square. This is y equals to basically x square. If you'll write x in the form of y, so this is what x is equals to root x, okay, root y. So this becomes your inverse function. You can write it like this, root of x also. You can just
So
replace y with x.
that means for two functions being inverse, f of x is equal to y implies f of y is equal to f of
See,
X.
first of all, whenever you will be given such type of problems like this is the inverse. Okay, this was pretty simple. Like root of x square ka, if you have to calculate the f inverse, you just have to calculate that function such that f of f inverse x is what should be equals to x, right? This is what you have to calculate, correct? Are you
Sir, I
getting
did
me?
not understand why
No,
f
I did
inverse
not get
x is equal to root
F
of x.
inverse.
What?
Why f inverse x is equal to root of x?
Okay, so basically, to get an inverse function, what do you do? To get an inverse function, whatever, if you have been given some function, let's for example, this is a function in given. How do you check whether this function is an inverse or not?
I don't know properly.
Sir, if f of x is equal to y, then that implies f of y should be equal to x. Then
Yeah,
only
to calculate, see, basically this was,
F
so
of f
whenever you have
inverse
been
of
given a
x should
question,
be
right?
equal to f of x.
Yeah, to check for any function that whether it's an inverse of that function or not, you basically do f inverse of fx should be equals to what? Fx of that should be equals to x, correct?
Yes.
And if you are getting for any function, whatever the function that you are checking for, so or you can say that f of, let's for example, this function was gx that you have calculated as an inverse. So you can put it like this: gx equals to g of x fx, that should be equals to x. If you are getting this, that means gx is the inverse of fx. Are you getting me?
No, sir.
Okay, maybe have you went through the lectures of the inverse? I guess inverse has been
Actually, I did not complete the week 5 totally.
so if you haven't seen that, first you should go and watch the like lecture first. That will help you, and then you can
Okay.
ask. So we have other sessions also. You can ask. So the
Okay.
basic thing was for the inverse function is, see, mostly what will be given. You'll be given the function, and then you'll be given the inverse of that also. You have to check whether this function is the inverse of that function or not. So some basics thing you should be knowing, that the given function is the inverse of the first function or not. How will you check? So this is the step that you check, okay, the function is a inverse or not of the given function. The other thing is, for what are the condition that will be getting inverse function? See, for this function itself, x square, as the domain is fixed from 0 to infinite, then only you will be getting the inverse, because you already know that you can get inverse of only a one function. You can't get a inverse of a onto function, okay, like okay. So for this function x square, basically earlier it was 0 to infinite, like minus infinite to infinite. We have just reduced the half what, we have restricted the domain to 0 to infinite such that it becomes a one function. You know that, you already know the
Yes, sir.
horizontal test, right?
Yes, yes,
So
yes.
it is a one function. Now you can get the inverse of that, and the inverse is pretty simple. Let's for example, I took inverse root of x as a inverse function of x square, okay. If you'll check this, if you'll check the, if you will calculate, if you'll put the x square inside the root x, we'll get the x. That means that it's an inverse of that function, correct?
Yes,
What
sir.
did I say? You calculate, you have a given function f, you have other function g. If you have to check whether the function g is the inverse of f is or not, then you calculate f of g, or you calculate g of f. If both are equals to x, that means you can directly say that this function is the inverse of the other function.
Okay, sir. Understand.
Okay. Yeah. So here it has been given that the function, whatever the given x square, and then let's for example, it's not been given the f inverse, root of x is also given that root of x is a inverse function. Now you have to calculate what? You have to calculate all those points where the function is getting, having the intersection, getting intersected. Okay. So that means what you have to do? You have to equate, right, these two function. This is the fx, this is the f inverse x. You have to equate this two equation, and if you are equating, now you have to calculate which are those values of x where this both function are getting intersected. What are the values that you can think of?
We can get zero
See,
or maybe
X equal to y, sir. Both are.
Yeah, see, x square is equals to root of x. You can do the square on both the side. You'll be left with x to the power 4 equals to x. And now you're left with x to the power minus x equals to 0. So now x cube minus 1 equals to 0. X, how can you, this is basically x minus 1 or something, x square plus x plus 1, correct? From here you'll not get anything. From here you'll be getting 0, and from here you'll be getting 1, correct? So 0 and 1 should be the answer. So from 0 you can get 0 0, and from 1 you'll get 1 1. Is it clear, or should I explain it again?
It is clear, sir.
See, it's just asking that which are the values of x where both inverse and fx is getting intersected. Is this clear, or should I do it again?
It is clear, sir.
Okay. Even though if you see the plot, okay, of x square, how do you plot the x square? This is basically here like this, right? Because this is from 0 to infinite. And if you see the root of x, that will be going like this. So this is the point 0 comma 0, and this is the point 1 comma 1, where the function is intersecting. Okay, if somebody knows the basic idea, but just the basic idea about the plot also, he'll be able to get the points. Is it clear to everyone?
Yes, sir.
Yes, sir.
So this was it for today's session. You can see that the plot also has been plotted here. Okay, so maybe we'll come again with some more and some other sessions are also there. So if somebody hasn't watched the lecture, please go and watch that, at least the lectures. Okay, and then you try to solve the activity question, practice questions, and then you come up with your doubt. Okay, so I guess this session would have helped you in some or other way. So some concept that you can't ignore is the domain function, the domain of the composite function. Basically, the composite function you can't ignore. And basic idea about the of exponent. So this all concept will get repeat again and again. Again in the 6th week and 7th week, 8th week, all this concept will be repeating again and again. So hopefully it'll be clear after maybe next week, 6th week. Again there is this concept will again come with the limit and then continuity, differentiability. So this all concept will be repeating again and again. So I hopefully it will be clarified if somebody has a doubt also in upcoming weeks and all. Okay. Yeah, so for any other doubts you can just ask on the discourse. Hopefully you'll get the scores also in one maximum today or tomorrow. It was about to release it in 2-3 days itself. I guess it will be released in upcoming 1-2 days. The score that I've seen is not that good, but it was not that bad also. At least it was better than the previous term results. But okay, so the next paper also will, I guess, day after tomorrow also you have a session on the Sunday, I guess, hopefully. And 6th is your deadline, I guess. 3rd is your when is the deadline for this week's?
6th March.
6th.
Wednesday.
Okay, Wednesday is the
That,
deadline.
that is for both the weeks, 5th and 6th.
Okay, yeah. So you have to rush up. You have to take care of the 6th week also. You just go through the 6th week also. We will discuss all the concepts of week 6 on Sunday session, and then we'll solve some problem most probably on the Tuesday session of the 6th week. I'll try to fix one more session for 6th week also, maybe Monday. So Sunday you'll be having session, Monday also, and then Tuesday also you'll be having session. Okay.
Sir,
Apart from, yeah, you're audible.
Sir, can you share your document?
Yeah, this document, okay, I'll share it. That's there on the portal also. This document is already there.
Okay, sir.
Yeah, it's there on the portal. So in the supplementary content, you go to the live session slides and then you can find the slide.
Yeah.
Okay. Okay, everyone. So yeah, goodbye, everyone. Yeah, thanks for attending the session. We'll meet again in the
Thank you,
Sunday
sir.
session.
Hello, sir.
Okay, thanks. Thanks, everyone.
Thank you, sir.
Thank you, sir.
Bye-bye.